Given this problem statement, let S subscript of n denote the sum of first n terms of an arithmetic progression. So if S subscript of 4 is equal to 16 and S of subscript of 6, that is negative 48. So in that case we need to compute the value of absolute value of S subscript of 10. Now proceeding towards the solution. So here it is given the fact that S subscript of n, right, S subscript of n, so this denote the sum of first n terms of an arithmetic progression. Now this is something which is already given, right? Now so we can make an assumption here that let the first term and the common difference of the arithmetic progression be a and d respectively. So here the first term is assumed to be a and the common difference is assumed to be d, right? So from this one we can write S subscript of 4, which is given equal to 16, right? So from this we can definitely state that, so from this one we can definitely say thus that 2 times 2a plus 3 times 2a plus 3 times d, this will be equal to 16, right? Because we are already aware of the fact, we are already aware of this fact actually, that is S subscript of n, which is representing the sum of first n natural numbers. So for this the identity is, or the formula is, n over 2 times 2 plus a, and here n minus 1 times d, right? Now this is the formula for S subscript of n. So on resolving this, we can write this equation as 2 times a plus 3 times d, that is equal to 8. And let us consider this one as equation 1. And then in the next step, I will replicate for the other given information, that is S subscript of 6, which is equal to negative 48. Now proceeding ahead with this, we can write, instead of S subscript of 6 we can write 3 times 2a plus 5 times d, that is equal to negative 48. So this further implies that 2a plus 5 times d, this will be equal to negative 16, and this one is considered as equation 2, right? And now we'll perform the subtraction operation, that is I will be taking this equation, that is 2a plus 3d, that is equal to 8, and the next equation I will write it here as 2a plus 5 times d, that is equal to negative 16. Now on performing the subtraction operation, so here if I perform the subtraction over here, so from this 2a term gets cancelled, so minus 2 times d, that is equal to 24, and this further implies that d is equal to negative 12. So the common difference is negative 12. So for this expression, that is 2a plus 3 times d, that is equal to 8. So from this we can substitute the value of d over here, that is 2 times a plus 3 times d, that is negative 12, that is equal to 8. And on solving this one, we will be getting 2 times a, that will be equal to 44. So now further, now I need to calculate S subscript of 10, and whatever is the value, we'll just compute the absolute value for this. So this would be 5 times 2 times a, and here 9 times d. This will be equal to 5 and then 2 times value of a. So value of 2 is already 44, right? Plus 9 times negative 12. Now on resolving this, we'll get the answer is minus negative 320, right? Now we need to compute, so therefore we can say that is the absolute value of S subscript of 10, that is equal to absolute value of negative 320, and indeed the answer is 320. So for this given problem statement, the answer to this problem statement is 320, right? And hence the solution and its answer is 320 for this given problem statement.